What if the most powerful cooling system available for your Barndominium wasn't mounted on your roof, wasn't sitting outside on a concrete pad, and didn't show up on your electric bill at all? What if it was buried 8 feet under your feet, quietly doing its job around the clock, using nothing but physics? Right now, Barndominium owners in Texas, Arizona, and Florida are getting slammed with $400, $500, even $600 electric bills every summer. And most of them have been told there's no real solution. Bigger AC, better insulation, maybe a dehumidifier. But there's a system that's been quietly used in Europe and the Middle East for decades. It taps into the Earth's constant underground temperature to pre-cool incoming air before it ever touches your HVAC. And almost nobody in the Barndominium world is talking about it. That changes today. If you're building a Barndominium and you're serious about not spending half your income on electricity every summer, this video is for you. I'm going to walk you through the engineering, the real numbers, the installation process, and honestly, the catches too. Because this system isn't magic. But done right, it's about as close as you can get. Stay with me through the cost section at the end. That's where the full picture comes together. Let's start with the truth that most builders don't tell you until after the concrete is already poured. Metal Barndominiums have a heat problem. A serious one. Here's the physics. Metal siding and roofing conduct heat at a rate that wood framing and brick simply can't match. On a 95-degree summer afternoon, your metal roof isn't sitting at 95 degrees. It's sitting at 150 to 170 degrees. That entire surface is radiating downward, straight into your living space, like a giant radiant heater mounted 6 inches above your head. Now add the volume problem. Most Barndominiums feature those stunning 20-foot vaulted ceilings in the great room. They look incredible, and they are incredibly difficult to cool. Hot air rises. It pools at the peak. Your AC unit, down at floor level, is fighting both the heat radiating from your roof and an enormous column of hot trapped air above it. The result? A typical 2,400 square foot Barndominium in Texas or Arizona needs a 5-ton AC unit running almost continuously from June through September. We're talking electric bills of $350 to $550 a month. Some owners in Phoenix and Houston report hitting $600 during peak weeks. Here's where most people give up. They assume it's just the cost of living in a metal building in a hot climate. They accept it. But what they're actually missing is this. The problem isn't that their AC isn't powerful enough. The problem is what the AC is being asked to do. Take 95-degree outdoor air. Drop it to 72 degrees. In one shot. Every minute. All summer. That's a 23-degree temperature drop, non-stop. And your system is burning electricity every second trying to make it happen. What if you could cut that job in half before the air even touched your HVAC? Instead of cooling 95-degree air down to 72 in one step, what if you pre-cooled it to 65 underground, and then your AC only had to close a 7-degree gap? That's a 70% reduction in cooling load. On paper, in real systems, in real homes. That's what an earth-air heat exchanger does. Here's the fundamental piece of science that makes this possible. About 6 to 10 feet below the surface, the Earth maintains a nearly constant temperature year-round. Doesn't matter what's happening above ground. 105 degrees in August, 28 degrees in January, 6 feet down, the ground sits steady between 60 and 65 degrees Fahrenheit across most of the United States. In hotter regions like Arizona or deep South Texas, it might be 65 to 68 degrees. But the key word is constant. It doesn't move. An earth-air heat exchanger, also called an earth tube system or EHE, works by running buried pipes through that stable temperature zone. Outside air enters an intake tower, travels through 100 to 165 feet of buried pipe, exchanges heat with the surrounding earth, and comes out the other end inside your home at 60 to 65 degrees. The physics is completely passive. No refrigerant, no compressor, no moving parts underground. The earth does the cooling. Now let me break down where the engineering actually matters, because this is where most DIY attempts go wrong. Depth is not negotiable. The sweet spot is 6.5 to 10 feet down. Shallower than 6 feet and you're still in the zone affected by seasonal temperature changes. The earth there fluctuates, and your cooling effect disappears in peak summer when you need it most. Deeper than 10 feet, and your excavation costs spike without meaningful return. 6 to 10 feet gives you stability. That's your target. Pipe run length matters just as much. You need 100 to 165 feet of buried pipe, not 30, not 50. The reason is surface area and contact time. Air moving through the pipe needs enough distance with the cool earth surrounding it to actually lose its heat. A 100-foot run gives you roughly a 10 to 15 degree temperature drop. Push to 165 feet, and you can hit 15 to 20 degrees of reduction in ideal conditions. For pipe material, there are two real options. HDPE, high-density polyethylene, is the professional choice. It's durable, corrosion-resistant, has a smooth interior for better airflow, and holds up for 30-plus years underground without degrading. PVC is cheaper up front, but it has lower thermal conductivity and becomes brittle with time when buried. For a system you're designing to outlive your mortgage, HDPE is worth the extra cost. Diameter: 10-inch pipe for residential systems is the standard. Too narrow, and you create excessive air resistance. Too wide, and you lose the velocity needed for proper heat transfer. Here's the detail that saves you thousands, and it's the kind of thing that only matters if you know it before you build. Instead of excavating after your Barndominium is finished, which is expensive, disruptive, and has to work around your foundation, you snake the earth tubes under your slab during site preparation. Before the concrete goes down, you're already moving earth for your foundation work. You're already digging, grading, leveling. The earth tube trenches happen at the same time, at almost no extra excavation cost. The pipes go in, get covered, and then your slab goes right on top of them. That one timing decision is the difference between a $6,000 installation and a $12,000 one. Now I want to talk about the two concerns that make people walk away from this system, because they're both real and both solvable. First, condensation. When warm, humid air moves through a cool pipe, moisture condenses on the interior walls. Basic physics. If you ignore this, you end up with standing water inside your pipes. And standing water in a warm, dark underground tube is a textbook breeding environment for mold and bacteria. This is the number one reason DIY earth tube systems fail. The fix isn't complicated, but it has to be built in from the start. Every earth tube system must be installed with a minimum 2% slope from the intake point down to a collection sump at the lowest elevation. That means for every 100 feet of horizontal pipe, the pipe drops 2 feet in elevation. Any condensation that forms inside automatically drains toward that collection point. At the collection point, you install a condensate trap, similar to the P-trap under your sink. It allows water to drain out while preventing air from bypassing your system. The collected water goes to daylight drainage, a gray water system, or a small sump pump if needed. In high humidity climates, coastal Texas, Florida, Louisiana, you may also want antimicrobial pipe coatings or a dehumidification loop integrated into the intake. Not optional in those climates. Essential. Second concern, air quality. People worry about pulling air through buried pipes, radon, soil gases, contamination. Here's how that's handled. At the intake tower, the above-ground structure where outdoor air first enters the system, you install a MERV 13 or MERV 16 rated filter. A MERV 13 captures 90% of airborne particles down to 1 micron, pollen, dust, mold spores, most bacteria, before air ever enters the pipes. For radon specifically, which is only a concern in certain geographic regions, you ensure your pipe joints are completely airtight and install a radon sump at the intake if your local geology warrants it. Radon is heavier than air and accumulates in enclosed spaces, not in continuously ventilated earth tubes with constant airflow. When properly engineered, the air coming out of your earth tubes is actually cleaner and more filtered than the outdoor air coming in. That's not a selling point. That's just the filtration doing its job. Now here's where Barndominiums have a hidden edge that most people never think to use. That 20-foot vaulted ceiling everyone worries about, the one that makes cooling so expensive, can actually become part of the cooling system itself. This is called the thermal chimney effect, and it's been understood by architects for centuries. Hot air rises. It will always rise in a Barndominium with tall ceilings. It accumulates at the peak of the roof structure. If you install an automated vent, a cupola, or a thermal chimney exhaust at the highest point of your building, that hot air has somewhere to escape. And here's the elegant part. As hot air escapes at the top, it creates a zone of lower pressure below it. That pressure difference, completely passive, no electricity, pulls air upward from the floor level. If your earth tube vents terminate at floor vents in your living space, that negative pressure at the peak literally draws the cool underground air up through the room. The hot roof is pulling the cool earth air in. They're working together. During a power outage, on a 105-degree August afternoon, while your neighbors with conventional AC units are sweating in the dark, your system keeps moving air. No fans. No electricity required. The greater the thermal differential, the stronger the effect. It works hardest exactly when you need it most. Add a small solar-powered exhaust fan at the peak, and you can push 200 to 400 cubic feet per minute through the system on a passive day. Combined with your regular HVAC for the final few degrees of cooling, you've built a hybrid system that most engineers would nod at with respect. Alright, numbers. For a typical 2,400 square foot Barndominium with a 150-foot earth tube system, here's what a real 2026 installation looks like. Excavation and trenching, integrated during foundation work, $2,500 to $4,000. Done after construction, that same work runs $5,000 to $8,000. This is why timing matters. HDPE piping, 150 feet of 10-inch diameter pipe with fittings, $1,800 to $2,500. Intake tower with MERV filtration, rain hood, and insect screening, $800 to $1,200. Condensate management, trap, sump, drainage, $400 to $700. Interior floor vents and distribution, $300 to $500. Optional solar-powered thermal chimney fan, $400 to $800. Professional installation labor, if you're not going DIY, $3,000 to $5,000. Total system cost, integrated during construction, $6,200 to $9,700 for DIY. $9,200 to $14,700 with professional installation. Now let's look at what comes back. A standard 2,400 square foot Barndominium in a hot climate needs a 5-ton AC unit. Running it through a Texas or Arizona summer costs approximately $380 to $550 a month at 2026 electricity rates. With an earth tube system handling the pre-cooling, you can downsize to a 2.5 to 3-ton unit. That smaller system costs $180 to $280 a month to run. Same comfort. Smaller machine. Significantly less electricity. The monthly savings, $200 to $270 during the 5 to 6 month cooling season. Annual savings, $1,000 to $1,620 per year. And that doesn't count the lower purchase price of a smaller AC unit, or the reduced wear and fewer service calls on a system that's working a fraction as hard. Payback period on a $6,200 DIY system at $1,300 average annual savings, just under 5 years. A professionally installed $10,000 system pays itself back in 6 to 8 years. After that, every year is money in your pocket. But here's what most people miss when they run these numbers. In 2026, documented low energy costs and passive cooling systems are increasingly meaningful selling points in the real estate market. A Barndominium with verified low electricity bills and an engineered earth tube system can command a 5 to 8% premium in resale. On a $350,000 property, that's a $17,500 to $28,000 in added value. Your $10,000 installation just became a $20,000 value add, before you've counted a single year of electricity savings. Check with your state energy office and local utility. Some programs offer $1,000 to $2,500 in rebates for qualified earth-coupled systems. It doesn't hurt to ask. Let me walk you through what this actually looks like from the ground up. During your site planning phase, you work with your excavation contractor to map out the pipe runs. Most systems use a serpentine layout. The pipes snake back and forth under the building footprint to maximize total length while staying within your slab boundaries. The intake tower is positioned 15 to 30 feet away from the building, oriented toward the prevailing wind. It's a simple above-ground structure, 4 to 6 feet tall, screened at the top to keep out debris, birds, and insects. Air enters here, drops down into the buried pipe network, travels through roughly 150 feet of earth-coupled pipe at 8 feet deep, and emerges through floor vents inside your living room, bedroom, or great room. You install manual or automated dampers at each floor vent. During peak heat, open them fully. During mild weather, close them down. In some climates, you can reverse the function in winter, using the system to pre-warm incoming cold air, though the savings on that side are less dramatic. Maintenance. People always ask about this. Replace the MERV filter at the intake tower once a year. Check the condensate trap once every 2 to 3 years to confirm it's draining cleanly. That's it. No moving parts underground. No refrigerant. No mechanical systems to break or service. Just physics, doing exactly what physics does, year after year. Done right. This system will still be working the day your grandchildren own the property. This system isn't for everyone. I want to be straight about that. It works best in hot, dry climates. Arizona, New Mexico, West Texas, inland California. Low humidity means minimal condensation, maximum temperature drop, and a system that runs as cleanly as the engineering promises. In hot, humid climates, Florida, coastal Texas, Louisiana, the system still works, but it demands more careful condensation management. You'll likely see 10 to 12 degree temperature drops instead of 15 to 20. Still significant. Still worth doing. Just with more upfront engineering attention. In already cool climates, Montana, Maine, the Pacific Northwest, you probably don't need this. Air conditioning loads are low enough that the return on investment won't justify the cost. This is the right move for you if you're building new in a hot climate. You can integrate the system during foundation work, and you plan to own the property long enough to see the payback period through. It's not the right move if you're retrofitting an existing Barndominium. The excavation cost after construction is nearly double, or if you're planning to sell in 2 or 3 years and won't recoup the investment. Those aren't reasons to dismiss it. They're reasons to be honest with yourself about your situation before you commit. Here's what actually changes when this system is running. You wake up in July. It's going to be 103 degrees by 2 in the afternoon. You know this because it happens every day. In a normal Barndominium, that means your AC has been running since 6 a.m., fighting the heat already soaking through the roof. By noon, the slab is warm. The air near the ceiling is stifling. You're watching the electricity meter spin. In a Barndominium with an earth tube system running, the floor vents are delivering 65-degree air. The thermal chimney is drawing it upward through the room, and the hot air is escaping at the peak. The AC runs for shorter cycles because it's not carrying the whole load by itself. The indoor temperature is steady. The building is quiet. And at the end of August, when your neighbor compares electricity bills, they're sitting at $490, yours at $230. There's no real explanation that feels adequate. Because the system that made the difference is invisible. Buried 8 feet underground, doing its job in silence. Barndominiums are remarkable buildings. Efficient to construct, flexible in design, genuinely beautiful when done right. But they inherited a real problem from the metal buildings they evolved from. They absorb heat with almost no resistance. The engineering answer to that problem isn't necessarily a bigger air conditioner. Sometimes it's a smarter starting point, pre-cooling the air before the battle even begins, using a temperature that's been sitting stable underground since before you broke ground. Earth-air heat exchangers won't make sense for everyone. But for the right build, in the right climate, with the right timing, they're one of the most cost-effective investments in the entire construction budget. The technology isn't new. The awareness of it in the Barndominium world is. If you've used earth tubes, a geothermal system, or even a solar chimney in your own build, drop your experience in the comments. Real-world data from real builds is worth more than any calculation I can run on paper. If this breakdown was useful, hit the like button and subscribe.